Hello everyone. Okay, so in this video we are looking at geometric sequences. So what is a geometric sequence? So a geometric sequence is a sequence in which each term is found by multiplying the previous term by a non-zero real number called the common ratio. So to check whether a sequence is geometric, right, we just kind of divide all terms after another. They are called something I forget. Anyway, so let's have a look here. So, for example, 2, 4, 8, 16. This is an example of a geometric sequence because I'm multiplying by 2 every time, right? And just to double check, it's geometric, you do 4 divided by 2 equals 8 divided by 4. 2 is equal to 2. Ding, ding, ding. It is a geometric term, right? What about now 1, 1/3, 1/9, 1 over 27? This is actually a geometric sequence. You might think we're dividing by 3, but we're not allowed to say dividing. So we have to make that multiply by 1/3. So we're multiplying everything here by 1/3, and we can find this by, so 1/3 divided by 1 equals 1/9 divided by 1/3. 1/3 equals 1/3. Ding, ding, ding. It's a geometric sequence. Therefore, the common ratio is 1/3. So this is the general formula for a geometric sequence. This is the nth term. So Tn is equal to a or to the power of n minus 1, where a is the first term and or is the common ratio. Let's have a look here. Find the nth term in T7 for the sequence 1/2, 1/6, 1/18, and 1 over 54. Hence, find the number of terms in the sequence that are the 1/2, 1/6, 1/18, 1/54, ... up to 1 over 39366. So we know the first term is equal to a half. That's fine. A is equal to a half. Now let's find our common ratio. So a common ratio is going to be, so A is equal to a half. Now my common ratio would be, well, I know it's geometric, right? But so it's going to be 1/6 divided by 1/2, which is 1/3, right? And I could do the same here. 1/18 divided by 1/6 is a third. So my common ratio is 1/3. So my general term, Tn, is going to be a half times 1/3 to the power of n minus 1. Now to find T7, T7 was just going to be a half times 1/3 to the power of 7 minus 1, which is going to be 6. The seventh term will be 1 over 1458. Now we want to find out finally how many terms are in this sequence. So I'm going to let Tn equal the last term here, which is 1 over 39366. So a half times 1/3 to the power of n minus 1 equals 1 over 39366. So divide by a half here, multiply across by 2. 1/3 to the n minus 1 equals, so 1 over 396,366. 196, no, so 19366 multiplied by 2 is equal to 1 over 19683. I now have a variable in the power, so you need to use logs. So base, answer, power, BAP. So log of 1/3 of 1 over 19683 is equal to n minus 1. This here should be equal to 1 over 19683 1683 1683. Sorry, my pen's a bit there. But my left hand side would be 9 is equal to n minus 1. Therefore, n is equal to 10. Bring over the 1 and add it. So that is 10 terms in that sequence. Let's look at some other problems here. The first three terms in a finite geometric series are x plus 2, 8x minus 4, and 13x plus 10. Find two possible values of x and hence find the first three terms. So it's a geometric sequence because they told me, so I don't need to test it. So what I do know in geometric sequence is 8x on it, 8x minus 4 divided by x plus 2 is equal to 13x plus 10 divided by 8x minus 4. Right, do multiply across now by 8x minus 4 and x plus 2. So I'm left with 8x minus 4 times 8x minus 4 is equal to 13x plus 10 times x plus 2. This is 64x squared minus, so 832 minus 64x plus 16 is equal to 13x squared plus 26x plus 10x plus 20. 64 minus 13 is 51. 51x squared. 36 minus 64 minus 36 is going to be minus 100x, and then 16 minus 20 is minus 4 equals 0. And this will equal to, I believe, 51x minus 2 and x 51x plus 2 and then x minus 2. So 51 times then, yep, that's there. Therefore, x is going to be equal to minus 2 over 51, and x is equal to 2. But it's telling me here x is a natural number. So therefore, x equals 2. And then the first three terms, you're just going to sub them in. 2 plus 2, 8 times 2 minus 4, and then 13 times 2 plus 10, which is 4, 6, 12, and 26 plus 10, 36. There's my first three. Finally, last one here. Right, consecutive terms. The product of the first three terms in a geometric sequence is 216, and their sum is 2, and the sum is 26. So the product of the first three terms in a geometric sequence is 216, and their sum is 26. Find the three terms if OR is less than 1. So I'm just going to let the three terms be x over OR, x, and x OR. So this is my first term. I then multiply it by OR, my common ratio, and then I multiply it by my common ratio again. So these are my first three terms here. The product of these terms, so x over OR times x OR, going to be where the OR will cancel here, and I'm left with x, going to be x cubed. The product is 216, so x cubed is equal to 216. So x is going to be equal to cubed root of 216, which is 6. Stunning. And their sum is 26. So it's going to be x over OR plus x OR is equal to 26. I know x is equal to 6, so I have 6 over OR plus 6 OR is equal to 26. Multiply across here by OR. 6 plus 6 OR plus 6 OR squared equals 26 OR. Bring everything over. 6 OR squared minus 20 OR plus 6 equals 0. Then the possible values are, well, I could divide across here by 3. A bit lazy here now. Right. So if you factorize this, you'll get, factorize and solve this quadratic, you'll get or is equal to a third and or is equal to 3. But up here in the question, if or is less than 1. So therefore, or is equal to 1/3. Then find the first 3 terms, but then I just sub or back in here, and I get 18 and right. So that's just a quick little video on geometric series. I'll do exam questions video, but I hope this video some helped you guys, and I'll catch you guys later. Bye.